So, I am going to discuss the GATE 2020 solutions of the morning paper of civil engineering stream. So the first question was like this. I hope everybody knows the questions. I don't want to write them here. So the question was like this: a 4 meter wide rectangular channel. So the data was 4 meter wide rectangular channel. That means width is, so question, width of channel is 4 meter and it is carrying a discharge of 6 meter cube per second. The Manning's coefficient is given like this, 0.02, and acceleration due to gravity was 9.81 meter per second square. So here the question was, what is the critical velocity? He is asking to find critical velocity. So generally, how can we find the critical velocity? First of all, we need to find the critical depth. That means when the Froude's number is equal to 1, the corresponding velocity is nothing but critical velocity. Okay, when the Froude's number is equal to 1. So we don't know the velocity here. So we need to find the critical velocity. For that, we need to ascertain the critical depth. Okay. So how to find critical depth? So we know this. Yc is equal to q square by g whole power 1 by 3. So this was a formula which we are very familiar with. So now here q is discharge per unit width. Q is discharge per unit width. So width of the channel is known. So from these two values we can find small q. That is nothing but 6 by 4. So this is q and you know g. So using this you can find the critical depth of the channel. We can find the critical depth of the channel. So the critical depth is coming around 6 by 4 whole square by 9.81 whole to the power of 1 by 3. It is coming approximately 0.6 meters. It is coming approximately 0.6 meters. We know that critical velocity is nothing but discharge by critical area. Okay, critical area is nothing but critical area, or else here if you divide this q, whatever the q you have calculated, so this is q per unit width. If you divide it with this y, also you will get the same velocity. So that is what I am doing here. So q by a critical is nothing but q by b by c, are simple. So that means once you get this value 6 by 4, so the 6 by 4 by this value is the answer. 6 by 4 by this is 6 by 4 by 0.6 is the answer. It is coming around 2.45 meter per second. 2.45. That means simply 1 by 4. It is a very simple question. If you understand it clearly, it is a very simple question. Okay. This was the first question which we have discussed. I will repeat it again. So in the question, width of the channel was given as 4 meters. It's an open channel. And the discharge was given as 6 meter cube per second, and the rugosity coefficient was given as 0.02, and the acceleration due to gravity was also given. It is a known value, 9.81 meter per second square. So what he is asking in this question is to find the critical velocity, rounding it to 2 decimals he is asking. Okay. Now the critical velocity, so we know the critical depth, how to find q square by g whole power 1 by 3. From that you will find critical velocity yc. So VCR is nothing but Q by ACR, that is nothing but Q by B by YCR, that is 2.45. Okay, this is one way of doing. So another way is also there, equating the Froude number to, what is the Froude number? So Froude number is equal to 1. What is the Froude number generally? Froude number is given as V by square root of G into D. Okay, D is nothing but depth of the channel here. So Froude's, what I told, for critical velocity condition, for critical velocity, so Froude's number should be equal to 1. So Froude's number is equal to 1. That means VCR by square root of G into YCR is equal to 1. So VCR is nothing but square root of G into YCR. So this also will give you the same answer, 9.81 into 0.6 is 2.45 meter per second. So this is also alternative way of doing. So if you know the width of the channel, so you can find small q. Once you know the small q, you can find YC. From YC you can adopt this way or this way, whichever is comfortable to you. So this is our first question. I hope everybody understood this. So we are going into the second question. The second question is from environmental engineering. From environmental engineering, the question was like this: a river has a flow. That means river has a flow. What is the flow value? It was given as 1000 million liters per day. That means MLD, with a BOD of, so this is reverse BOD 5 milligram per liter, and DO of river was given as 8 milligram per liter before receiving the wastewater discharge at a location. That means this is a river. So somewhere a sewage is coming and entering into the river. This is sewage and this is river. So now before entering, that means on the upstream part. So if this is a section on the upstream part, these are the properties. Before wastewater discharge at the location. For the existing environmental conditions, the saturated DO, so for that the DO saturated for this river should be 10 mg per liter. Wastewater discharge, so now wastewater discharge is 100 mld. So the wastewater which is coming, so this is for river discharge, wastewater discharge is QW, which is 100 mld, the BOD 5 of 200 mg per liter, and a DO, and DO level of 2 mg per liter falls at that location. Okay, at this location the DO has fallen to 2 mg per liter. Assuming complete mixing of wastewater and river water, the immediate DO deficit. So immediate DO deficit, what is the immediate DO deficit? That means this is saturation DO. So now after mixing, the DO will get reduced. That means DO, because of this BOD, it will consume some DO. So what is the deficit DO he is asking now. Now what is the DO of the mixture after mixing? Okay, what is the DO of the mixture after sewage entering into the river? That means, so DO of the mixture is equal to, so river into DO of river plus wastewater into DO of wastewater by discharge of river plus discharge of water. Now what is the discharge here? So using this formula, 1000 into 8 plus 100 into 200, no, not 200, 2 by 100,000 plus 100. That means this is the DO of the mixture, 7.45 mg per hour. So after mixing of this sewage water into the river water, the DO is how much? 7.45. Now what will be the BOD? So BOD, I think BOD is not necessary here. He is asking only deficit of DO, right? So saturation DO is 10 and the DO of the mixture is 7.45. So the deficit of oxygen is equal to DO saturation minus DO of mixture. That means 10 minus 7.45, that is equal to 2.55 mg per liter. This is the oxygen deficit we are having because of entry of the sewage water into the river water. Okay, this is also very simple questions. So say maximum questions in the GATE are very simple. The third question is from transportation engineering. So a road in a hilly terrain is to be laid. That means in a hilly terrain, a road to be laid at a gradient of, so the gradient was given as 4.5 percentage, a horizontal curve of radius. So radius of horizontal curve is equal to 100 meters. Gradient needs to be used because it is a horizontal curve. So because of this horizontal curve coming on the path, so the gradient should be eased. Otherwise what happens? The vehicles may skid or topple in the horizontal curve. So that is why the grade compensation we need to give. Okay, so the question was gradient needs to be eased due to the combination of curved horizontal and vertical profiles. Okay, so as per IRC, this was everybody knows this. The compensation will be minimum of 30 plus, so the minimum of 30 plus R by R or 75 by R. So whichever is minimum, that we will provide. If it is lesser, that means if you got this value lesser, you will give this only. If you get more value than this, then you will provide this. Okay, so whichever is the minimum, we will provide that. So 30 plus R, so we know that 100 is the radius of horizontal curve. So, and what is this value? 75 by R, 100. So it is coming around 1.3% and 0.75. So whichever is minimum, we will opt this because this is minimum. So 0.75 percentage. So you will provide a gradient compensation of 0.75. That means, so grade compensation after grade compensation is equal to 4.5 minus 0.75, that is equal to 3.75. But as per IRC, a minimum gradient of 4%. It cannot be eased more than 4%. Okay, so this is the minimum. So though you are getting 3.475, you have to restrict to this value. We cannot ease beyond the 4% value. That is why the answer should be the 4% only. Okay, so next one is a theoretical question. The question was a body floating in a liquid in a stable state of equilibrium. If it is, that means, so a body can be in stable state of equilibrium. See here, two terms we generally know, that is one thing is the center of buoyancy, another one is metacenter. So center of buoyancy and metacenter. Generally, center of buoyancy we consider for partially or fully submerged bodies. Generally, center of buoyancy we consider only for partially or fully submerged bodies. For floating bodies, generally we consider the stability of a floating body like ships and all, we use metacentrism concept. So we all know that it may be metacenter, it may be center of buoyancy. So stability can be attained only when the metacenter or center of buoyancy is above the center of gravity. I think you might know this in the fluid mechanics topic. We learn this concept. Generally in the fluid mechanics topic, generally we learn this. So, for example, when a ship is like this, okay, for example, so what is metacenter? If the center of buoyancy, it may oscillate, it may take any positions. So this is center of gravity. Now metacenter is defined as the point of intersection of all the buoyancy lines. So this is metacenter. So this is center of gravity. For example, this is center of gravity. Now always the moment of center of gravity, it acts downwards. The force of gravity always acts downwards, and we all know the buoyancy always acts upwards. If the metacenter is at the top, if the metacenter is C, if the weight is moving this way, the gravity will shift towards the location where the weight goes, right? For example, so this is the surface of water. Now the ship is moving this way. That means it has attained a shape like this. So now the ship is attained a shape like this. Now the gravity, the weight is moving this way. That means the gravity, new location of the gravity also moves this way. Now what happens if gravity is moving this way, the metacenter will move on the either side, this way. Okay. Now what is happening? It is creating a couple. Which is making it to stabilize. That means whatever the couple it is coming, that means this tries to move this ship in clockwise direction. See, this moment will cause a clockwise moment, and this one will cause a clockwise moment. So it's a clockwise couple. If a ship is moving anti-clockwise, when the metacenter is at the top, when the gravity is at the bottom, they cause a clockwise couple when the ship is moving in anti-clockwise direction. So it is stabilizing, it is giving its original path, original shape or original location. It will come back to its original position. So this is called stable equilibrium. That means it enhances the stability. When metacenter is at the top, when center of gravity is at the bottom, it can regain the position. That means it is in stable equilibrium. That is what the question says. I hope you understood. If you don't understand this, you can post your doubt in the comment. Okay. Now the answer should be metacenter lies above its center of gravity. That is the answer. Okay. Now the next question is from soil mechanics. So majority of the questions came from soil mechanics. Again, this is also very, very simple question. So what was the question? See, whenever you solve a gate paper, first figure out what are the data that is given in the paper and what is the formula. So whatever the data is present, what formula can be used with these parameters given. So if you can correlate them, half of the preparation is over. So concept, you need to understand the concept also, but apart from that, if you know the formula, at least with those parameters you can solve something. Okay, so now in this question, in a drained triaxial compression test, a sample of sand fails at deviator stress. So the deviator stress was given as 150 kilopascal, and under confining pressure of 50 kilopascal, he is asking angle of internal friction. So he is asking angle of internal friction. What is the angle of internal friction? Now, so what is a deviator stress? If you do triaxial compression test, so how generally we do triaxial compression test? So first of all, we will put cell pressure all around the soil sample. We will first put some cell pressure. So this is cell pressure sigma c. Okay, after some time we will put additional stress, that is called deviator stress. This is deviator stress. We know that this is minor principal stress. Sigma c is, this is minor principal stress, and this one sigma d plus sigma c is major principal stress. This is major principal stress. So it is simple. We generally, in shear strength topic, we generally use the concepts of stresses and strains and strength of material. Okay, similarly, so this is major principal stress, this is minor principal stress, or we can call it as sigma 3, this is sigma 1. So in the plastic equilibrium, when the soil attains plastic equilibrium, then there is a relation called sigma 1 is equal to sigma 3 tan square alpha f plus 2c tan alpha f. This was the formula generally we have derived when the soil attains plastic equilibrium condition. So here it was quoted that it is a sand sample. So for sand sample, so this value cannot be existing. So simply sigma 1 is equal to sigma 3 tan square alpha f. So sigma 1 is nothing but the summation of these two, that means 200. Sigma 3 is 50. So this is tan square. What is alpha f? 45 plus 5 by 2. So where phi is angle of internal resistance, which we need to find here. So using this formula, so 50 4s are, so tan 45 plus 5 by 2 is equal to 2. So square root of 4 is 2. So this is nothing but 5 by 2, we approximately we will get it as 16 or 17, I think so, 17 point something, 17.5. Phi is equal to, or 18.5, I think so, 18.5, 1836, yeah, approximate values. So phi is equal to, so tan inverse, doing tan inverse you will get this, okay, it's not a big deal. So phi we are getting as 37 degrees. So again I am repeating the same question, listen carefully. So in a triaxial compression test, this is a soil specimen or soil sample. So on this soil sample we will apply confining pressure throughout the soil sample, that is nothing but confining pressure or cell pressure. Okay, so this is a sigma c, which was given as 50 kilopascal, and after some time we will put a deviator stress on the soil sample. So this is additional stress apart from this confining stress. So if you see this plane, this is sigma d plus sigma c is acting on this plane. On this plane only sigma c is acting. So this plane we take it as whatever the total stress which is acting on this plane, we take it as major principal stress, and on this plane we call it as minor principal stress. So if the soil before failure of the soil attains a equilibrium called plastic equilibrium condition. So in that plastic equilibrium condition, so sigma 1, so we are taking this as sigma 1, we are taking this as sigma 3. The relationship between the major principal stress and minor principal stress and the cohesion is given as sigma 1 is equal to sigma 3 tan square alpha f plus 2c tan alpha f. Okay, so using that condition, by substituting sigma 1 and sigma 3, and c is 0 because this is sand. For sand material, cohesion will not exist. That is why we can assume c as 0, and using that condition we can take this statement as 0. Rest of the thing, substituting rest of the thing, you will get the answer. Okay, so the next question is also a theoretical type of question. Velocity of flow is proportional to, so velocity. So what is Darcy's law statement? Generally in soil mechanics, what is the Darcy's law statement? Darcy states that velocity is proportional to hydraulic gradient. So what is the statement of Darcy? Velocity is proportional to hydraulic gradient, and the proportionality constant is coefficient of permeability. But there are some assumptions kept in mind, so before deriving this equation. So we apply this Darcy's law in soils. In soil, if you speak, the velocity of water will be very negligible, right? So the velocity of the soil, so the water cannot have any turbulence inside the soil strata. It will have only laminar kind of flow because of the velocity is very less. The soil has to move through the pores of the soil particles, so that is why generally the velocity is very less. So we can safely assume that the flow inside the soil strata is laminar. So by assuming that only, Darcy has derived this Darcy's law, V is proportional to I. So that is why that is a statement. So this law is applicable to, so laminar as well as turbulent is not the right answer. Transitional flow is also not the right answer. So laminar flow is the right answer. Laminar flow in porous media is correct. Okay. Now the second question, the next question is from RCC. They have asked it from RCC. 1 second. So what is the stress distribution? So a reinforcing steel bar partially embedded in concrete is subjected to a tensile force P. The figure that approximately simply what he is saying is, so he has inserted, so this is simply for understanding this, just hold a pen in your hand, and try to pull it tightly. So where you will find more stress, at the beginning of this or at the ending point? See, when you are pulling this pen, where you will be having more stress concentrated in your hand, just understand this, you will understand that also. So generally the bond stress at the beginning will be higher, gradually it gets diminishes when it is reaching to its other end. So simple thing is this is the profile of the bond stress when a rod is embedded into a concrete beam. So this is what the question. So the option is this is the option actually. So this is the correct variation. Okay, so you can understand this simply by practical understanding, also by just holding a pen and pulling it. Also you can understand in a better way. Okay, now next question is also again from soil mechanics only. So in a soil investigation work at site, a standard penetration test was conducted at every 1.5 meter interval. So now, this was a soil strata. So at every 5.5 meter interval, they have taken one standard penetration test. Okay, one SPT test. Up to the standard penetration was conducted at every 1.5 interval up to 30 meter depth. Up to 30 meter depth they have did this up to 30 meter depth consecutive 1.5, 1.5, 1.5, 1.5 like that. They did up to 30 meter. At a 3 meter depth, the observed number of, so at the 3 meter depth, so this point, the number of blows required for 3 consecutive, at 3 meter, the observed number of hammer blows for 3 successive 150 mm settlement penetrations was 8, 6 and 9 respectively. So what is SPT? So what is the SPT at this location? Okay. So generally SPT was defined as the settlement, the number of blows required for having a settlement of 300 mm. Okay, so generally the first one number of blows we neglect generally. So we will take only the next 2 consecutive set of data. So the set of data which is giving 300, this is 150, this is 150, this is 150. The first 150 mm data we neglect generally. So we will take the rest of the 2 data. So 9 plus 6, that is 15 is the, so 9 plus 6, 15 is the standard penetration test number of blows using SPT experiment. Okay, using SPT standard penetration test. Okay. Next. So during chlorination, again next one is again a theoretical question. So let us discuss the theoretical question. During chlorination process, chlorine reacts rapidly with water to form, so the chlorine forms, so 3 components generally. The chlorine compound, when Cl2 so reacts with H2O, when Cl2 reacts with H2O, so it forms HOCl plus HCl. Okay, when Cl2 reacts HOCl plus HCl, and again this HOCl upon ionization it forms H plus OCl minus depending upon the pH. So depending upon pH. Okay, now in this question what is asking? The most active disinfectant in chlorination process. So he has given 4 options. Option A is Cl minus, option B is H plus, option C is HOCl, option D is H2O. Okay, so which of the following are better? He is asking active disinfectant. So active disinfectant means, see, one thing I will tell you. So many of the people think that chlorine should be the most active disinfectant, right? Many people think like that only, chlorine is the most active disinfectant. But here chlorine was given with a charge. It is an anion now. It is no more stable matter. It is active matter because of negative charge. So first it will think, forget about disinfection. What it will think? First it needs to get neutralized. So the Cl minus will search for a cation rather disinfection first. Once it meet the cation, it gets the electron, it gives the electron to the cation, then it will stabilize itself and then it will start disinfecting. So keep in mind that whenever there is a charge, why OCl minus is less effective than HOCl? We have studied that HOCl is around 80 times more powerful disinfectant than OCl minus. Why OCl minus? Because OCl minus is also coming from HOCl only, though it is less active disinfectant because of its charge. OCl minus first tries to nullify its charge and then it starts doing disinfection process. So that is the reason why all the 3, so H2O is a dipolar, though the charge appears or not appears, it can exist either in a positive cation or anion. So that is why the charge, it is neutral only. So rest of the options, if you see, the confusion lies between A and C. There won't be any confusion between B and D. We are clear that B and D are not disinfectants. So HOCl is a better disinfectant because it is not carrying any kind of charge on its top. Okay, so this is the reason. And yeah, again a theoretical question. Which of the following statement is not correct? The ultimate bearing capacity. The statements were, just hold a moment, I will erase and write. So I will read out meanwhile. So the ultimate bearing capacity of a strip foundation, the ultimate bearing capacity of a strip foundation on a surface of a sandy soil increases in direct proportion to the width of the footing. So the question was like this. First statement was ultimate bearing capacity of a strip footing supported on soil increases in direct proportion to the width of the footing. So what is the formula for ultimate bearing capacity? CNC gamma D NQ plus 0.5 gamma B and gamma. Let it be whatever the corrections are of there, leave it. Just we are thinking of in a strip footing. So for a strip footing, generally the length is infinite. Okay. Second, so this is what the equation says. What is the second option? B. A clay deposit with a liquidity index greater than unity is in a state of plastic consistency. So liquidity index, what is liquidity index? What is liquidity index? Liquidity index, a clay deposit with a liquidity index greater than unity in a state of, no, it is not correct, because what is how we generally define liquidity index? W, tell me the formula for liquidity index. The formula for liquidity index is W minus WP by WL minus WP. This was the formula for liquidity index. What is saying? The liquidity index greater than unity. So this is greater than 1. He is saying that liquidity index is greater than 1. That means, so how it can be greater than 1 when W is greater than WL, isn't it? See, if it is WL, then it is 1, right? If W is equal to WL, then it is 1. When W is greater than WL, then it will be greater than 1, isn't it? Now if W is greater than WL, then it is in liquidity consistency, not in plastic consistency. When W is less than WL, that means if this is shrinkage limit and the water content increase, this is plastic limit or plastic consistency up to plastic limit. When the water is beyond plastic limit, then it is liquid limit. Okay. So here, if this is the location, he is saying here it is in liquid consistency. It is in liquid consistency. So here, how can the soil in plastic consistency? So plastic consistency will be present in between these two, up to plastic limit. Beyond plastic limit, it attains a liquidity consistency. Beyond liquid limit, it behaves like a liquid completely. So plastic consistency here is impossible. So that is why that is the wrong answer. Rest of the questions, it is time waste for analyzing the rest of the questions. So simply it is clear that a clay deposit with a liquidity index greater than unity is a state of plastic consistency is a blunder. So that is why we can directly solve it using the option B. Okay. Next question is also from soil mechanics. Just wait a moment.